No questions at all? Felt good about PEF number 5? Let's see, is there anything? Okay, we're solid, 100% good. No questions, good on distributing. Yes? Sure? No fibbing? Okay. Hey, I want to look at number 19 though real quick. Just because number 19, they flip-flop things. Now, I just want to make sure you feel comfortable even if they flip them over. Okay, so you agree they're flip-flop, meaning the letter doesn't come first on both, right? So if you do this, you're going to get 36 plus 6y minus 6y, and then minus y squared. Combine your like terms. Those are gone, right? And you could totally leave your answer like that. You don't have to change the order of it. Okay? So that's just one that kind of came to mind that might stumble you a smidge. Not because there's anything wrong. It's just like, it looks different. And then I want to make sure 21 you feel comfortable with. That's the 2x minus 3y and the 2x plus 3y. So again, we have multiple letters. So if I multiply here, I'm going to get 4x squared. If I multiply the outside, I'm going to get plus 6xy. Notice I made it alphabetical. And then there, I'm going to get minus 6xy and minus 9y squared. Those cancel each other out. So I get 4x squared minus 9y squared. And that always happens when you have the same exact binomials with one sign different. Yes?
Couldn't you just leave it as the 4x minus 6xy minus 6xy? Does it say fully?
Yeah, well, if you multiply it out, and the only reason you get rid of it is because positive 6xy and negative 6y, they just eliminate each other. So if you put it, you're okay. But like if from here on out, like if you see like these are two opposite values, they'll just cancel each other out. That cool? Cool. All right, I gave you some notes. Let's see. I'm just gonna kind of remember what I gave you because I made the copies the other day. So we're gonna take care of 6 and 7 today, which is fine. This is a few pages, and then I have the notes already for Thursday or Friday, depending upon where you are. And then in here are also the notes. Ooh, we will have our remote class on Wednesday because we don't have school Monday or Tuesday. So a week from tomorrow, we're on remote, okay? And I'll remind you that. Cool. All right, so these are some problems that we've seen. So remember, when we have x plus 3 and we have a quantity raised to the second power, that means I have 2 of these. So write it down twice and then multiply it out. These are like terms, so we go ahead and just add them together and get to that. Seem good? And then again, because I have 2 of these, that means I'm going to write x minus 4 and x minus 4. Multiply them out. Now notice these, the middle terms aren't falling out. It's because they're the exact same sign. So it's when you have opposite signs that they fall out. Does that all make sense, my friends? Any questions about those? Pretty straightforward, right? Okay. So now we got this big old long thing. Oh my goodness. So we have to remember when we're multiplying like bases together, so in this case our bases are x, we add the exponents. So multiply here, so that's going to get me 5x to the 7th, because 3 plus 4 is 7. Then I multiply here, and that gives me plus 15x to the 6th, because 3 plus 3 is 6. And this then gives me plus 5x to the 5th, because 3 plus 2 is 5. That gives me 35x to the fourth. And then the very last one, that gives me 10x to the third. We do not have any like terms here because we have different exponents on each value, so there's nothing for us to put together. Good enough for now? And my friends, do not ever let someone tell you they're ashamed by you putting your distribute lines over the top. If that's how your mind sees it, please continue to do it that way. I get so frustrated when teachers are like, oh, they're showing it wrong. Is your answer right? Well, yeah, but then there's no but. Their answer's right. Let their mind work the way it should. All right, so now we're going to start reversing. We're going to start reversing what we were doing. We're no longer going to distribute. What we're going to do is we're going to look for a greatest common factor. So I'm going to break these down. So 7 can't be broken down in anything other than 7 times 1, so I'm going to keep that. But 14 can be broken down to 2 times 7. Do you agree with that? Now, I have two terms. I have two terms up there. I have 7x and I have 14. 14 just happens to be 2 times 7. So we're going to look. Do I have something in common between the two? And it looks like I have a 7. So I'm going to bring a 7 out front, and then I'm going to make parentheses. So if I factor a 7 out of 7x, I'm left with an x. Yep. And if I factor 7 out of 2 times 7, I get this. So we have just undone what we were doing. So we're starting on our venture towards factoring, okay? You want to see what I did? Now, my friends, again, I'm gonna keep breaking these numbers down. You might start seeing patterns a little quicker than that. That's fine, but I just want to, for sake of everybody, make it work. So I'm going to break 12 down into its prime components, its smallest components. So I'm not going to go 1 times 12. I know that 12 is 2 times 6, and I know that 6 is 2 times 3. Let me just stop there for a minute. Do you agree that 2 times 2 times 3 is 12? And 2, 2, and 3 are all prime numbers. They're the smallest makeup of a number. And then I have x squared, so I'm going to write x squared as xx. Okay? Does everyone feel comfortable that 2 times 2 times 3 times x is 12x squared? Any part of that doesn't make sense? Now I'm going to go to the 18. 18 I know is 2 times 9. I know that 9 is 3 times 3. And then I have an x. Okay, and I guess I could put a dot in between those two like that. So that's this problem broken down. Agree? So I have a 2 here, and I have a 2 here. Are there any more 2's that I could factor out between the two different terms? Yeah. The term is this. I could factor out a 3 and a 3. Anything else? And a single x, good. So what I'm taking out front is going to be a 6x. Where'd that 6x just come from? Yeah. Yeah, 2 and the 3 and the x. So that is my greatest common factor. That's the largest amount of things I could factor coming out of it. Okay, so now I'm going to put parentheses, and I'm going to look back. It looks like I have a 2 and an x left here, so I'm going to write 2x. Bring that sign down, plus 3. Nope. Because you have that plus sign in there, so you need to account for that plus sign. And then you have to realize, okay, I had 2 terms originally. If I distributed that 6 back over, and here you could double check it. If you went 6x times 2x, do you get 12x squared? I sure hope so. If I multiply 6x times 3, do I get 18x? I hope it works. And I kept my signs consistent. So we are undoing what we had been doing. We had been distributing over. We had been getting rid of parentheses. Now we're given a problem, and we're going backwards. We're trying to get it back into parentheses. Does that make terminology make sense, my friends? Cool. May I move to the next slide? All right, so I'm going to take a look at this one. So I know I have this negative. So I have 2 terms, and I have a negative. I know that 4 is 2 times 2, and I know I have an x. Do you all agree that negative 2 times 2 times x is negative 4x? And then that plus sign needs to come down. I know that this is 2 times 2 times x times y. Does everyone agree that 2 times 2 times x times y is 4xy?
Yep.
Yep. Now we're going to look. Okay. Both of them, right? And what else?
Axes.
Yeah. So 2 times 2 times x is 4x. There's a little bit of a gotcha here. Good. Minus what? Everything factored out. What has to be a placeholder in math? Nope, I already took the x out.
Then it'd be negative x plus y.
I agree with this so far. But I need to figure out what I'm going to put right here. What goes right there? A what?
1.
1. Yeah, 1 is our placeholder in math. So let's double check to make sure that we did this right. If I distributed 4x times negative 1, do I get negative 4x? Yep. If I distribute 4x times y, do I get 4xy? Uh-huh. So the big trick on that one is make sure if everything factors out, you have to have a 1 as a placeholder. Okay. Next problem, let's take a look at this. We're going to do, let's see, 3 won't break down, but x breaks down to x times x. 6 breaks down to 2 times 3 times x. And 9 breaks down to 3 times 3. All right, so we need to look at our 3 terms and see what we have in common. Do they all have a 3 in common? They do. Is there anything else I have in common between all 3 terms? Look at the very last one. Is there an x at the very last? No. So a 3 is the only thing I can take out of there. And so I'm left with x times x, which is x squared. Bring that plus sign down. I have a 2x here. Bring that plus sign down. And I have that 3. So this problem has been broken down. That's as far as we can break it down. Does that make sense? So if you redistribute over, just to double check your work, is 3 times x squared 3x squared? Is 3 times 2x 6x? And is 3 times 3 9? It is. So this is my answer. We factored out a greatest common factor. So we undid the distributing. Okay? I left coffee someplace around here. I found it. It's behind the bucket. Someone asked, hey, why am I teaching on my tablet? Sometimes I don't want to be at my board. Sometimes it works nicely. Sometimes it doesn't. So, plus, I'm not in anyone's way. I don't have to do my dance routine up there. All right. We're going to keep going with this adventure. I'm going to break 15 down to 3 times 5. And then I have times x, 2, 3, 4, 5. Minus 10 is 2 times 5, x, x, x. Agree? Let's count up the x's on the left. So I get 3 times 5, that's 15, and then x, 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 x. All being multiplied together gives me x to the 5th. Yes? And then on the right side, I have 2 times 5, which gives me the 10. And then I have x, x, x. And that's x to the 3rd if I multiplied them. Okay, so now we have 2 terms still. What do we have in common? Do both terms have a 3? No? What about a 5? How many x's? 3. I got 1, 2, 3, and 1, 2, 3. Agree? So outside, I'm going to factor 5x, x, x. X, x, x is x to the 3rd. Agree? And then I have parentheses. What do I have left here? I have this, and I have these two. So what is the 3 and the xx going to look like? What's 3xx multiplied? 3x squared, thank you. Bring the subtraction sign down. And then I have just that left. There's my answer. So let's double check to make sure we got it right. 5 times 3 is 15. X to the, oh, I forgot something. That should be a squared, right? So good thing I was double checking. So x to the third times x to the second. Add the exponents, x to the fifth. 5 times 2 is negative 10. X to the third comes along. Hey, we got it right. That boxed in thing is my answer. The one with way too many colors. But hey, we have the colors. We should use them. All right, that next one. Let's see. I know I have this negative, and I have 2 times 2, and then times 1, 2, 3, 4. And then 12 is the same thing as 2 times 6. 6 is the same thing as 2 times 3. 1, 2, 3. And 8 is the same thing as, and there's a minus there, 8 is the same thing as 2 times 2 times 2. Agree? So I have 3 terms. 1, 2, and then don't forget this one. So how many x's can I factor out, or excuse me, how many 2's can I factor out of both? 2 of them? I got 1, 2, I got 1, 2, and I got 1, 2. Agree? So if I factor 2 times 2 out, I have a 4 outside. Can I factor an x out of all 3 terms? Yeah. Ooh, that's a great answer. Great question. I like that. Does the negative go with it? I would say, so let me finish it this way, and then I'm going to show you, you're absolutely right thinking that way. So there's actually going to be 2 scenarios that could take place. But let's finish this way, and then I'm going to show you where that negative can take place. All right, do all 3 terms have an x? No. So I have x, 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 which is x to the 4th. Bring the plus sign. Oh, don't forget the negative. Make that plus. Looks like I have a 3xxx, which is 3x to the 3rd, minus that last 2. So that answer is 100% appropriate, but Josh brought up a really valid point. We have this negative sitting out in front. So what would happen if I brought that negative out in front? What do you think? Well, what if I do this? I want to highlight what I just did. Whoops, I'm not with a crayon though I like crayons. So let's say I pulled this out. Notice here, here, and here versus up here. What do you notice about all the signs? Yeah, they all, so the whole thing is they all flipped. So which answer is the most correct answer? I agree. So you got 2 different things you want to show. Josh, was that kind of what you were thinking? Cool. I like it. I like it. Good, keen eye on that. So, again, which answer would you like to be your answer? Your choice, my friends. Either one of those. Is there one that's going to be more right than the other? Not right now. Maybe like, 9 math classes from now. Like Calc 19 or something. May I move forward, my friends? Good to go? All right. Oh, I have some different letters. So let's see. 30 is the same thing as 2 times 15. Agree? 15 is the same thing as 3 times 5. Do you agree? 2 times 3 is 6. 6 times 5 is 30. And then I have my P's. And then a Q. Then minus. 20 is the same thing as 2 times 10. 10 is the same thing as 2 times 5. So that's what that's going to break down to. So I still have 2 terms. We just have broken them down. You want a 2? Can I do both 2's, or is it only one of them? Okay, what else?
1 P and a Q and a 5.
A 5, a P, and a Q. A 5, a P, and a Q. Okay, so if I take out a 2 times 5 times P times Q, that's going to give me 10 PQ. Agree? And I'm going to do parentheses. All right. So I have a, oops, let's make that blue. I have a 3, a P, and a P. What's 3PP? 3P squared. Great. Bring the subtraction sign down. And I have just that. Nothing else. That's my answer. We can double check it. 10 times 3 is 30. P to the first times P to the second is P to the third. And then Q. Cool. First term works. 10 times negative 2 is negative 20. P and Q. Yeah, it works. It works. So there's my answer. So we're factoring out a greatest common factor. Agree? So it's just kind of reverse thinking. Coffee time. That's a good cup. All right, moving on. Okay, a little bit bigger. Again, I'm going to go through the exact same way. 12 is the same thing as 2 times 6. 6 is the same thing as 2 times 3. Times x, times x, times x, times y. Agree? Plus, 20 is the same thing as 2 times 10. 10 is the same thing as 2 times 5. And then I got x times y minus 8 is the same thing as 2 times 4. 4 is the same thing as 2 times 2 times x times y. So I have 3 terms still up there. So what does it look like I have in common between the 3? Do they both have a 2? Yeah, we have 2 2's, right? What else?
An X and a Y.
An x and a y? What do you think?
That's it.
So 2 times 2 is 4, so I have 4xy that comes out. Let's take a look. I have a 3 and an xx, so that's 3x squared. Bring the plus sign down. I have a 5x. Bring the minus sign down, and a 2. It's done. We can double check it. We can go 4 times 3 is 12. Good. X times x to the second is x to the third. Good. Times y. Good. 4 times 5 is 20. Good. X times x is x squared. Good. Times y. Got it. 4 times negative 2 is negative 8. Good. xy comes with it. Yay. That's my answer. So we reversed them. They're just reversed. Seem okay so far, my friends? Can I move on? How many more I got? I got that one. Okay. Oh, hey, this is my last slide. Are you kidding? Best day ever. Hey, this one, we don't really have any numbers, but we have 2 terms. We have this one and this one. So I have 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. Plus 1, 2, 1, 2, 3, 4, 5. Uh-oh, ran out of room. Times 1, 2, 3. Okay, what's the most x's I can factor out from both? 2. I got 2 here, and I got those 2. All right, so I know x squared is going to be outside. What's the most y's? 3. I have all 3 of those. And I have these 3 here. I could have picked any 3. It doesn't matter. So y is y to the third. How many z's? 3. So I'll take those 3 and those 3. Z is z to the third. And now I'm going to have some parentheses. Well, what's xx? Xx and zz is what?
X squared and Z squared.
Good. Oh, it's not plus. I'm sorry. I'm like adding like stuff to this problem. I like it. Bring the plus down. What do I have left over here?
2y.
Which is?
Y squared.
Done. There's my answer. Woo! I like it. I like it a lot. I think I get it. All right, so I'm going to go back in time. What exactly did we work on today? PEF 6 and 7. Hey, so this is going to be 2 pages. I would like you to do the odds on both those pages, please. So PEF 6, PEF 7. It's 2 pages worth. So front, back. And I want you to do the odds. I'm going to give you the opportunity to start it now. If you need to take a picture of it, I'll open it up on my book up front. And I'm going to hit stop on my recording. Sound good?